Counting number of triangles in a figure part 2. Consider a square like this. If we join the center to the vertices, the square will get divided into triangles. To count total number of triangles in this particular figure, on looking at this triangle, we can identify these four triangles easily. But there will be many other triangles that are formed by combining two triangles at a time. Say this would be the fifth triangle. In similar way, if we combine another two triangles, we will get one more. In that manner, if we count, there would be 4 into 2, 8 triangles in total hidden in this particular figure. In our previous video, we have seen how to count triangles within a triangle when we join the vertex to the base. The process is just see the individual triangles we are able to recognize and add them. That will give the total number of triangles in that particular figure. Now, these two techniques can be combined to answer many other questions that are related to counting the triangles in a figure. Let us see again for the square. When we join from the center to vertices, along with that, there may be lines joining to the sides as well. Now, see this example. Here we have two lines joining the vertices and one joining the midpoint of the sides. Even in this case, we just have to mark the number of triangles that we are able to see individually without any overlap, and count should be multiplied with 2 to give the total number of triangles in that particular figure. Now consider another example. Here we have a square within the square and a number of lines joining towards the vertices or towards the midpoint of the sides. Here we have to count the total number of triangles for the external square and the internal square separately. When we mark like this, we will get 8. 8 into 2 gives the total number of triangles for the external square. Even the center one looks similar. So this will also have 8 parts. For this, we again have to multiply 8 with 2, that gives 16. In total, we will have 32 triangles in this particular figure. Consider this figure now. Here we have a triangle over a square. For the square again, we can easily tell that it has got 8 parts. So only considering the square, we will have 8 into 2, that is 16 triangles. And for the above triangle, we already know that it will have 1 and 2. So 1 plus 2 we have to make, that is 3 triangles. But when we keep one over the other, these parts are now combined to give another bigger triangle. On this side we have one, in the similar way we will have on the other side as well. So these two triangles are also there. So for 16 we have to add 3, along with that 2. So the 21 is the count for this particular figure. And now consider this. So we already know the lower square makes 16, the first triangle will make 3, and these two parts combined will make 2 more triangles. Now check this. Here we have one triangle, say A, and this triangle is combined with this particular piece again. So in that case, it makes another triangle here. So these two A's are making count 2. Similarly, here also we have another piece of triangle and this triangle. So this counts individual, and then these two combined will make one more. So that is 2. Apart from these, there is another bigger triangle combining all the 3 triangles here. So this triangle also looks to be in this form when we consider the internal lines. Check here, we have got a vertical line and there is a base, and these two standing lines are there here, right? So this is a big triangle, so even that will make 3 triangles. Combine this here. So in total we will get 28 triangles here. Consider this figure. Now we have one square and triangles over all the four sides. So the count for one square is 8 into 2, 16. When we have triangle over square like this, and these two parts of the triangle and square are combining to form another triangle, in that case each individual triangle will make 3 and 1 plus 1 2, overall 5 triangles because of this overlap one over other. So in similar manner we have 4, so 4 into 5, that is 20 here. So we will have 36 triangles in total. Consider this case wherein we have square beside square. Within one square we have 4, so 4 into 2, and like that we have two squares, so again into 2. This gives 16 triangles. Along with this, as these two figures are joined in this particular line, we will get two more triangles, 1 and 2, like this. So we have to add those two triangles, which gives the count to be 18. Now consider this figure. Here we can see that we have four individual squares joined together. So for the individual squares, again each square has got four parts. So 4 into 2 is number of triangles for one square, and like that we have four squares. So 32 till here, and at the point of joining for two squares we know there will be two other triangles. So like that, how many we have here? This is one joint, the second one, the third one, and the fourth. So every join will make 2, so 4 into 2, that is 8 triangles because of this joining. Again from the overall picture, this is one figure, triangle, 2, 3 and 4. So we have, apart from these two counts, 4 other triangles. This counts up to 44 triangles in this figure.